Hey, Doozer Shop. Got a quick little, kind of a strange thing, but engineers are known for doing strange things. Behind the Colchester 17, I got this lamp on it. It is a fluorescent, got two 13 watt or 19 watt lamp bulbs, light bulbs in there. And it's a gooseneck lamp. And it came with the lathe. When I bought this lathe, it came with it, and it was on top of this contactor box. And when I redid everything, I kind of put it back, and it's a good spot for lighting up, you know, the chuck and where you're working close to where the tool bit is. Anyhow, point I wanted to make with all this, I'm going to bring you close and let you look at this label, right? I hope this focuses. Oh. Well, I hope it, I hope, there you go. It says 45 Spring Street, New Haven, Connecticut, all right? And I also want you to notice something else. Oh, shoot, I'm the world's worst cameraman. Those are two stainless steel Allen head screws, 1032, and there's clearance holes in the top of this box. And maybe you can see, that one. Well, hard to see, but there's, let me should shunk this camera down. All right. There's one there, and one there on the other side. So they're threaded at the bottom, okay? So really what's going on is this is a cast aluminum box. It's a 5-sided box, and the back opens up. And what's inside here is 2 transformers and 2 starters for the fluorescent bulbs. And you can see the attachment, the cover is attached to the screw there and screw there diagonally across. And there's like little, you know, cast-in bosses at this diagonal and this bottom diagonal. But what was happening is, you know, this socket's in on the bottom here, right? And there's a post that is just in this little cavity, this protrusion, and the weight of the lamp, this gooseneck screws in the top, and there's a little nut in there. Anyhow, this box was spreading, right? It was opening up, right? This top was bowing up from the weight of the lamp, putting a twist, trying to pry that top off the 5-sided box. So I thought of different ways to fix it or reinforce it, and you know, so I came up with the wires come in from the power cord in the middle, and I had these long 1032 screws. So I drilled 2 holes in the top, and then I drilled and tapped on the bottom for those bolts to go through. So these are pretty long screws, they go all the way down. And with the 2 of them, the power cord goes in between. So that's the only obstruction. It wasn't broken, but it was bowed up. I'd say it was bowed up a good, not a 1/16, not quite an 1/8. And there was a gap at the bottom too where it stretched also. So maybe an 1/8 overall. But by putting these screws, you can imagine one comes down this side of the cord and one comes down the other side. It keeps the 6th side of this box, this open 5-sided box, constrained for the force of the lamp trying to, you know, put a cantilever on it. Now, what they could have done, and they probably didn't know that this was a problem, because the material kind of was, I guess you could say it was creeping over time. Maybe not. Maybe. Creep happens really slow, and this thing's really old, so maybe it's creep, or maybe it just got, you know, dropped or twisted at one time pretty hard. Somebody really wanged it, but I don't know, it doesn't matter. But you could redesign this part, right? Engineers love to redesign things. And instead of the screws being in diagonal corners, you could have, one screw here and one screw at the bottom. You could do it a little diagonal or a little top and bottom, or actually no reason you couldn't move the cord up like, a 1/4 inch and put one directly at the bottom and directly at the top. To complete the straight line force connection, going diagonally really doesn't add to the force connection, it just holds the cover on. Then the cover would be a structural member in tension. But, I chose to solve it with this. Kind of silly, but I really like this lamp. And the reason I brought up 45 Spring Street is Sargent is on Spring Street, I believe, or right around the corner. I forget their address exactly. But I've been up to the Sargent plant in New Haven, Connecticut, and talked to all the people in different departments, and great bunch of people over there at Sargent. Talked to some of the other engineers. They got the engineering upstairs, and the test lab, which I was interested in, is on the first floor. And I talked to all the assemblers building the locks, and all the latches and all that, and the electronic keypads. Everyone's super awesome over there at Sargent. But anyways, I just recognized, when I was driving from the hotel to the Sargent plant, man, I was driving around. I knew Spring Street was right around, I kind of take note of the street. I'm trying to navigate and da-da-da-da. But Spring Street is right basically across the street, 1 block away from the Sargent plant. So that's kind of cool. Oh, Electrix is the name of the lamp, Electrix. And they're still there. They're still there making lamps, made in USA, obviously, New Haven, Connecticut. They got Electrix has a website. They're kind of expensive, but I think their market is like industrial companies, a lot of hospitals, medical, where you want a lamp that's really good. Classrooms and government stuff. They don't mind paying for quality because it's going to last a long time. But Electrix lamp, I love this lamp. Like I said, New Haven, Connecticut, and I just found it interesting that I remember the street, and I drove past this place, and then I got all excited when I made the connection. I went on Google Earth and checked it out. I'm like, yeah, man, right there on the ocean there, the harbor. So I love talking about industrial stuff. So at Sargent, I talked to this guy, Al Saunders, right? And he's been there for forever. And Al is, I think he's a manufacturing engineer. I think he was almost ready to retire. But anyways, Al told me all about the Sargent plant. And all the tools they used to make. They used to make parallel pliers, and they used to make spanner wrenches, all different kinds of wrenches and pliers and everything. But Al Saunders told me that where the Sargent factory's built there, that plot of land used to have the Eli Whitney's company. Right? And you say, you guys remember Eli Whitney's, or most people say, oh, he invented the cotton gin. Yeah, well, Eli Whitney invented interchangeable parts. He was the guy that made the guns and submitted them, I forget, to the Army or to the Navy. And 10 guns, and he laid all the parts out, and he swapped them on the table, and they were all interchangeable. So that's modern interchangeable parts, modern manufacturing. That's Eli Whitney, and he had his factory there where the Sargent plant is now in New Haven. And also after Eli Whitney had his factory there, which also, Eli Whitney, became part of the Pratt and Whitney company. And Pratt and Whitney, of course, is known for their gauges, their thread gauges, their plug gauges, their all kinds of, mostly thread gauges, but like Joe blocks and them type of gauges. And of course, I've got the Pratt and Whitney lathe in the background, and I've got the Pratt and Whitney jig bore source there outside in the high bay. So I love Pratt and Whitney. So after Pratt and Whitney occupied that space, or I don't know if there was a Pratt and Whitney plant or it was just something that Eli Whitney had his plant there making guns. You heard of Robert Fulton. Robert Fulton occupied that plot of land with his factory. And you guys remember Robert Fulton made the steam engines, the Watt steam engines for the paddle wheel boats on the Mississippi and wherever. Fulton also made a lot of the stationary power generation engines and power plants, used by the municipalities across the United States. I think Tubal Cain did a factory tour somewhere. And they had a Robert Fulton, or a Fulton Engine Works engine powering the generators at one of the plants. So pretty cool. Eli Whitney was there, Robert Fulton was there, and now it's Sargent Manufacturing, which I'm affiliated with in my day job, and so I thought that was cool. Got this lamp from Spring Street right by the Sargent factory, and I love industrial history, so I kind of like to bring you guys along, because when I get into this stuff at work and the machines I do here at the shop, I truly feel like standing on the shoulders of giants. Everything I touch, nothing's boring because I know the history behind it, and it's so impressive to me, the history. Before I had the This is the Clearman upright drill, right? It's got 12 speeds and 9 down feeds and whatever. Before I had the Clearman, I had a Superior, a 1913 Superior Camelback drill, and it was 1913, something like that. But Superior. I sold my Superior drill press to Jonathan W. If you guys don't know Jonathan W., you got to go subscribe to Jonathan W. Anyhow, he's got my Superior drill press made in 1913 in Kokomo, Indiana, right? And my buddy Jim C. on Grand Island, he literally had at the time probably 10 or more Camelback drills, and he said, "Doozer, which one you want to buy?" I was going to buy one off him. And he had Barnes, and he had Canadi Autos and all, but the Barnes had the planetary back gear, and the Superior has the just open spur gears, like a lathe, old-fashioned lathe would. So I says, "Jim, I want to buy the Superior." Okay. So I had that for a while, and incidentally, right now, in Texas there, gentlemen with the planer, like Steve Watkins, my brain's failing me. Steve Watkins is trying to sell his Superior drill press. I had the same one. So Superior, Kokomo, Indiana. Kokomo, Indiana is famous for Hayes. Hayes invented stellite, which is a nickel alloy used a lot in valve seats and exhaust valve seats for car engines and all that stuff. Right there in Kokomo. And I think, I might be wrong, I believe this is correct, that the Hayes pioneered like Hastalloy, another nickel-based alloy, and Waspalloy and all that kind of stuff. So he was into those high-temp alloys. But every time I used the Superior, I thought of stellite, and I thought of Hayes, and I thought of all the stuff that was going on at that time in that city, and high-speed steel. The discovery of high-speed steel was awesome, and it revolutionized machine tools, because before you had high-speed steel, and the property of high-speed steel means it retains its red hot hardness. It wouldn't get soft. The previous tool bits were just hardened steel, and when you got the regular, medium to high carbon steel hot from the cutting process in the lathe or making drill bits out of it, and it'd get weak and just, the edge would be gone. But high-speed steel developed in Kokomo, Indiana by the Hayes Company, because you could run the material, the work faster, or the cutting tool faster, the lathes sped up. The manufacturers of lathes made them spin faster. The manufacturer of drill presses made them spin faster. The manufacturer of milling machines made the mills top RPM be able to spin faster. So lathes went from a top speed of 300 to 500 RPM to like 900 to 1000 RPM with the discovery of stellite for use in tool bits. And of course, when tungsten carbide was discovered, invented, compounded, whatever you want to call it, then lathes got faster yet, right? Now you might have a 2000 RPM top speed or more. And of course with mills, even 4000 milling machines. So I just love the history of the industrial world and how it changes the way machines are built. And it's a part of our culture. Just remember, folks, that cell phone you love so much, if you didn't have machines to make vacuum tubes, to make transistors, to make microchips, to make integrated circuits, to make microprocessors, to miniaturize these chips and crystals and plastic molds and glass molds. Everything that you touch is a direct, machines worked on it, whether it be lathes or mills or CNCs, everything. So I'm just rambling. I get jazzed about this stuff, and I hope you guys do too. But anyhow, back at you there. Spring Street, New Haven, Connecticut. Check out Electrix. I don't know. Just be happy in the shop. Catch you next time. This is Doozer Shop.